Γεια σας, με λένε William. Είμαι Βρετανός και Αμερικανός. Μένω στη Νάντι, στη Γαλλία. Είμαι σύμβουλος στο Zenica. Hi, my name is William. I'm British and American. I live in Nantes in France, and I'm a consultant at Zenica. I'm afraid that I won't be able to speak much more Greek, so please forgive my English. Has this happened to any of you? You decided to go on holiday, to go away on holiday. Has that happened to anybody? Yeah? Maybe less recently? And so you think about where you're going to go, you pick the perfect destination, you have it in your mind, and you think of all the activities that you're going to be able to do when you get there, and all the fun you're going to have, and all the souvenirs you're going to buy, and you come away with that. And then a few days later you think, oh, the date's coming close, maybe I should book my stuff, book my hotel, book my flight, etc., etc. So you go online and you look at the different hotels, and there are lots of hotels to choose from at your destination, various different prices, various different services, locations, etc., etc. You kind of try and wade your way through that. And you manage, after a while, a few hours, to select the hotel that will fit your budget and has a nice location. And then you look to the flights. And so you put in the dates, and you're just thinking about all the cool stuff you're going to do, and suddenly things start going wrong. You find out that there were fewer flights than you thought to the destination that you want to go to. You realize that means that either you're going to have to spend less time on vacation, or you're going to have to go there maybe a day earlier or leave a day later. So that means that you're going to have to book an extra night in the hotel. So you start playing around with different options. You start getting very flustered. You start getting a bit warmer, a bit more sweaty. You keep looking around. You keep comparing other hotels. The prices keep going over your budget. You put in some other options, and all the while, the prices keep going up and up, because you're driving prices up through your interest, and they want you to buy as quickly as possible. After quite a few hours, you end up not booking anything. You cancel your reservation at the hotel, and you just go away very dissatisfied. Has this ever happened to somebody in here? One person who's had that experience? Yeah, okay. Have you ever started a JavaScript project? And you thought, okay, so we're going to start this. So let's initiate the project. So which builder are we going to use to build the project and to download the dependencies and everything for that? Okay, so you look at the choices and you think, okay, NPM, that's the standard, let's do that. And then somebody says, no, 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 NPM's for losers. You should be using Yarn. By the way, does anybody remember Bower? Bower, yeah. That used to be on my slide 2 years ago. So somebody says, no, you should use Yarn. Okay. And then somebody else comes in and says, no, 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 Yarn, no, 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 that's has-been, that's has-been. You should use PNPM. And then somebody else starts saying, no, you should use NPM, and they just keep fighting in the background. You decide to choose something, and you go on. Okay, now what framework are you going to use? Are you going to use Angular? Are you going to use React? Are you going to use Vue? Are you going to use Lit or Stencil or any of the 20 other frameworks that are out there? You manage to make a decision after that. Now, how are you going to pack your deliverables? How are you going to package it all up into something that's nice and small and portable and will use the least bandwidth possible? Are you going to use Rollup? Are you going to use Webpack? Are you going to use Vite? Has anybody heard of Vite here? Yeah? Okay. So you just keep going through these various decisions, and at the end you think, well, maybe somebody's made all these decisions for me. Maybe somebody's made a template. Maybe somebody's made a tool to scaffold all these decisions, so I can just press on one button, and all these decisions have been made for me. So you look at how you can scaffold a JavaScript project. And there are several solutions as well. Are you going to use Yeoman? And somebody comes and says, no, Yeoman's old. It doesn't do all the fancy features that other things do. And then you look and you see there's NPM init. And a lot of projects, a lot of frameworks are starting to use that. Or if you chose React, there's the Create React project, et cetera, et cetera. And then somebody chimes in and says, oh, you should use this cool thing called Hygia that you've never heard of before. We have yet to deliver value to our customer. We have yet to make a decision that is actually related to the business. Now, I mentioned JavaScript. We have other problems that we find in other programming language ecosystems. It's not necessarily inherent to JavaScript. I like JavaScript. I'm not here to say anything else otherwise. But we do have sometimes a lot of trivial decisions, and are these decisions actually benefiting us? Are they bringing value to the customer? And are they giving us joy? Is that what we really want to be doing with our lives? How can we get stuff done and also feel good about it? That's what I'd like to try and explore with you today. Because there are various issues around here. One of the issues is one of sustainability. In an Agile project, in the Agile Manifesto, suggests that we should be able to sustain the pace that we're at. And if we're making all these small decisions and they're taking a lot of energy away from us, well, that's drawing energy from something else, other decisions that we need to be making. And is that going to be, will we be able to keep that pace up indefinitely? A larger issue is one of sustainable in the ecosystem. If we're spending a lot of time and energy on these trivial decisions, what kind of impact are we making on the environment? Are we going to be able to make the crucial decisions that are actually going to make our application less hungry in resources? So what I'd like to do is to do a quick overview of how do we actually make decisions as human beings, not how we would like to think that we make decisions. How do we actually make decisions? Quick overview, and then give you a few suggestions as to what you can do to minimize to make your decision-making more efficient and to minimize the trivial decisions that you might want to make. So how do we choose? We all know that human beings are extremely rational. We collect the data, we analyze the data, we debate the data, we come to the most plausible solution to the problem, and everybody's very happy with that and satisfied with that. Everybody comes to complete consensus very easily, and the decision that was made is definitely the right one. Are we all in agreement with that? So that's how we make decisions. Or not. We are actually emotional beings. We carry a lot of different emotions, and we use that to evaluate our decisions as well. And emotion isn't necessarily a bad thing. In fact, it's a very positive thing. In fact, it's a very necessary thing in our evolution in order to make decisions rapidly. And it happens a lot in tech. If we take Docker, for example, Solomon Hykes admitted in this tweet that choosing Go to implement Docker was pretty much an emotional decision. He liked Go, it was fun, and he thought that other people would adopt Docker for the same reason. And so afterwards, he tried to rationalize it after the fact, but he had to admit that it was primarily an emotional decision. If we go dig into a little bit into philosophy, well, we can see that also David Hume said that reason is and ought only to be the slave of the passions. The passions is emotion. So our decisions, in the end, generally rely on a certain amount of emotional judgment. If you ask why, many times, don't know if you use the 5 whys sometime to find out the root cause or the root reason of something. If you ask somebody, why did you do this? Why did you do that? Why did you do that? And you keep asking, at one point, you're going to end up with the answer, I don't know, I just felt like it. And that's fine, that's normal. Another factor we use is observation. We observe other people around because they're there, and we like to see, well, what happens if they pick that berry? Do they die? Do they get ill? Maybe if they are quite well after eating that berry off that tree, then I can probably eat that berry off that tree. This is a picture of the hype cycle. That's one description of how we observe the ecosystem and make decisions based on that. Another similar description is here taken from Diffusion of Innovation, which was built upon by a book called Crossing the Chasm by Geoffrey Moore, where we can see that generally most innovations follow this kind of life cycle. And generally, people who adopt an innovation are in roughly one of 4 categories. Now, don't put people into boxes. These aren't always completely strictly observed, but generally this order is seen. And there are different reasons why different people adopt a project. So usually the early adopters, they like a project because of how it's made, what's the engine like. They like to open up the car, see what the engine is, take it apart, look at all the pieces, wow, this is great tech, put it together, and they don't really care what it does. The next people, the early majority, they adopt a product because of why. They don't really care what's inside the thing. They don't care that Docker's implemented with Go. They just want to know what Docker can do for them. Afterwards, the late majority, they neither care nor what is Docker made out of or what it can give them. They just adopt Docker or any other innovation because other people are doing it. And then we get to the final category, people who really don't care about any of that stuff. They adopt the product because they have to. And there's no problem with that. There are certain things that I'm a tech geek. I like a lot of tech things. I really like Docker. I was probably one of the early adopters. But there's some tech that I'm more of a laggard. I adopt it because other people kind of force me to, and there's no real problem about that. Geoffrey Moore identifies that there's a chasm between the first two groups. You can see that there's a totally different way to market the innovation. First, you market what's inside, and then you don't market what's inside. You market what it can do for you. And Geoffrey calls this a chasm because he estimates that there are many products that fall into the chasm that never make it out again because they never manage to pivot their marketing schemes towards a different message that will actually allow the early majority to come. And the last remark about this is that you can see there's this sort of hill. The early majority is a moment where there's more and more adoption. The market is stabilizing. It's a time when the market is not ready for new ideas generally. You may have the greatest idea, like as Docker was picking up, you might have had Uber Docker that was so much better than Docker. But at that time, when Docker was being adopted initially, there was no market for anything else. People would not listen to that. You have to wait until the curve starts coming down to get across the other side of the hill, for frustration to start to build up, and for new ideas to be able to come into the market. Another factor that we mustn't forget is luck. We generally underestimate the impact, the role of luck in success or in failure. So don't forget that. So that's a basic overview. If you want to go more into detail, I'd suggest you look into various books about neuroscience or papers about that. This wasn't a very necessarily scientific description, and so if you want to really take more, draw more conclusions, I would advise you to go read up on these things. So now, what can we do to make better decisions? Well, what I'd like to suggest is that we need to recognize that there are different contexts, as you saw in a product's life cycle, in an innovation life cycle. There are different contexts, and therefore there is no one method that will fit every context. So I'd like to give you a tool that will allow you to do contextual decision making. And I'm going to, for that, I'm going to rely on a framework called Cynefin. Cynefin is a Welsh word which means the place of multiple belongings. Cynefin is a sense-making framework created by Dave Snowden over 20 years ago. And in it, in this version, one of these versions that we see on the left, we see that there are various domains that you can be in, that, an issue, a problem that you can be in. And in these different domains, clear, complicated, complex, chaotic, and the central domain is called aporia or confused, well, there will be different decision-making methods that can be applicable. For instance, the clear domain. The clear domain is the domain of predictability that is known to everyone. For instance, if I switch the switch, if I press the light will turn on. If I press the button the other way, the light will turn off. Everybody knows this. It's very clear, very simple. In this domain, you apply best practices. There's one way to do it. It's the best way. Everybody knows it, so just do it. Why bother making a decision? It's already been made for you. This is also a domain where there can be complacency. At some point, a best practice no longer becomes the best practice because a new technology comes in and disrupts the market, and you have to change the best practice. This means that you have to be wary of complacency, and you have to take time to look at new tech that's coming on, not necessarily always integrate it in what you're doing, but take time out of your workday to look at new tech and to see what it can do for you. And that way, when the time comes for that tech to be adopted, well, you're already well on your way to doing that. Some examples of the clear domain in code, in tech, would be indentation. Please stop debating spaces and tabs. And code style. Code style, for most languages, there are code style guides, and there are even tools that will reformat your code automatically based on those style guides. And a lot of CI tools can be integrated so that it will check that everybody is adhering to that style guide. So don't bother debating that. Another thing that I hope you don't fight over, unless you're in a very specific domain in tech, is sorting algorithms. Has anybody debated which sorting algorithm to use? No. Please don't. Just use what's in the standard library, unless you have a very specific case that you need a very optimal algorithm. In general, when things are clear, when things are simple, don't overcomplicate them. If things are in fact complicated, well, we need to use, there are not necessarily best practices. There isn't a single best practice to apply. Complicated is the domain still of predictability, but this predictability is not known to everybody. There are experts who may know, and so if you have experts, ask them. Don't make the decision yourself. Ask the experts for plausible reasons to believe that their expertise is applicable and that their analysis is correct. If you don't have experts on hand, you can try and analyze the problem yourself and gain the expertise that is required. Another thing is that experts should share their expertise continually when it's needed. And that isn't necessary just in writing. Certain forms of knowledge are very good in writing, books and blogs and such. But some things need to be experienced. We need to pair a program together. We need to do a bit of apprenticeship together to be able to gain that kind of experience. Some examples are testing strategies and security. These are things that people have a general knowledge of certain best practices, but not of everything. And so we need experts to be there to help us. And also in the case of testing, well, it's nice that the people who are testing experts aren't the only ones who are writing tests, that they're actually helping to explain to other developers, these are different techniques that you can use to write tests so that this information gets shared amongst all the developers. If you're in the complex domain, this is the domain where there isn't predictability. You can't predict what the market is going to want, for instance. Any action will have unintended consequences. So examples include large-scale distributed systems. In these systems, failure is the norm, and we can't always investigate why. We'll try, but sometimes it's very difficult to reproduce a failure in a distributed system. And most of the time, the important thing is just to fix the failure, and then if things come up, if you get some better ideas about the problem later on, then you might be able to remediate it for the future. A huge example of the complex domain is organizations and teams. How humans behave is wildly unpredictable. Yes, it is constrained within certain limits, but within those limits there is a great deal of variability, a great deal of different responses that people can have to the same things. And so, since we can't predict that, then we need to proceed cautiously. Here are a few ways to handle complexity. One thing is that we need to generate lots of different ideas. And to be able to easily generate lots of different ideas, we need diversity in the group of people who are ideating, who are giving ideas out. This is where diversity of many different kinds, cognition, origin, culture, practice, experience, etc., is key. And generating different ideas is extremely important. People talk about thinking outside the box. Well, it's actually almost impossible to think outside your own box. To be able to think outside your own box, you need somebody who's outside of that box to help you. One important thing is also to do the next right thing. Don't try to plan too far ahead, because that planning is probably useless. Do what's right, do what's coherent. You can't prove that that's the right thing, but it is the option that has the most, that seems the most coherent. Keep options open. Don't force consensus in complexity. We've generated a bunch of options. We've maybe narrowed down to what's coherent. And let's not try and narrow it down to one single thing. Let's try different things in parallel and see what works. And let the market decide. This is in complexity. Try not to be decision makers yourselves. Try and do it as a community, and also bring your customers in, your stakeholders in, and have them decide based on actually trying it out. This is a great place to document your decision-making process as you're doing it, and one format that I suggest is architecture decision records. If you click on the link when I've tweeted the slides already, so you can get all these resources and links. An architecture decision record, you document at first the different options that you're going to explore, and then as the actions that you're going to use to explore those options. And then once you've done your different explorations, you can then document what the outcomes were and why you ended up choosing a specific option. A couple principles to follow in this space is, when you try something new, do it on a scale where failure is survivable. Your explorations are going to fail. Most of them are going to fail. Some of them will succeed. Make sure that that failure is not going to bring down the company. And another thing is, try to explore different ideas, at least 2 or 3, because in this space, nothing is more dangerous than an idea when it's the only one you have. And another quote I would like to give is the retrospective prime directive, where after the fact, try not to second guess what you did. Just recognize that everybody made the decision that they could make, given the resources that they had at the time. So let's give a couple of examples of how we can kind of do this in practice. One example is what's called Plan, Do, Study, Act. Now, Plan, Do, Study, Act is a very limited way of exploring different options. There are many other ways to do it in complexity. This is a very limited way, and it doesn't work when things are completely uncertain. There's so much uncertainty. It works when there's you have a rough idea of what direction you want to go in, but there are a few things that need to be ascertained before. So in Plan, Do, Study, Act, what we do? Well, we make a plan, we execute the plan, then we take a step back and we look at what happened, and then we act in accordance to what we studied. What does this accomplish? Well, it tends to make certain arguments completely unnecessary. Instead of talking about things, why don't we do something and see what happens? It also makes it so that when we do eventually argue, well, we actually argue about facts instead of ideas that are fictitious. It also, and this is, I think, very important, it allows the team and the code bases to mature at the rate of the team. So many times, I see even experts coming into teams, coaching teams, and telling them, if you don't do this like everybody else, you are doomed. If we're in the domain of complexity, this is completely wrong, and it's counterproductive for the team as well. I don't know if you've heard of FOMO, fear of missing out. This is a similar problem. Let's all adopt new tech when it feels right for the team. And that may be years later after the tech comes. And you know what? That might be even better, because it might turn out that that tech was actually wrong to apply in that situation. And after a few years, with some hindsight, we learned that we didn't need to use that. So respect the rate that the team wants to evolve in. Now, to do better Plan, Do, Study, Act, it's good to have malleable code that can be changed easily. And there are a few ways to make your code more malleable. Well, if it's disposable, if you can just throw it away, it's very short. Well, that's one way to make it malleable. A lot of microservices do this. If there's there's weak coupling, and so decoupling between services, that means that you can refactor part of it without disturbing the rest. That helps code to be very flexible. And as a final technique, there's test-driven development that I'd like to zoom in to right now. TDD, test-driven development, is not just writing tests before your code. It's not just unit testing every single function, and it's not a substitute for other form of testing. What is it? Well, it's kind of plan, do, study, act. The plan is you write a test that fails. Do, you write code. Study, you look back, take a step back and see why that code works. And then act, you refactor it based on the learning that you've just produced. What does this accomplish? Well, in the plan phase, you choose an outcome and not an output. In the do phase, you experiment. You're exploring different ideas. And in fact, you can do several things in parallel at this stage. When you study, you generate learning. And when you act, you prove that your code is flexible by actually flexing it, by actually changing it. And I'd like to finish with an example. Has anybody used Java 1.1? No? OK. Well, we're going to go back in history a little bit and see how a specific, very simple case could have evolved over time. Let's take the factorial function. So here's the interface. And here's one possible implementation in Java 1.1. Very simple. It passes all the tests. OK, Java 1.2 comes along, and there are collections. And everybody's like, yes, we should do collections. And you're like, oh, I don't know. And then a couple years later, a newcomer comes in and says, oh, I really like collections. I can do it well. Maybe this is the time to do it. OK, very good. As long as it passes the tests, OK. And this new person comes up with this code, and it passes all the tests. And so you go, oh, that seems very readable, very nice. OK, let's keep that. Java 5 comes along, generics and for each loops. Have some people used Java 5? Yeah, we start to get a few hands. And so we rewrite that code. The whole team agrees that, yeah, this whole non-generic thing is a bit of a pain, and having the for each loop really simplifies part of the code. It passes all the tests, so great, we keep that. Java 7 comes along, great tools for concurrent programming. This is a problem that could be optimized with concurrency. So that's what somebody comes up with. And so you go, OK, you're skilled with that? OK, try it out. We'll give you a few days. If you manage to do it in a few days, then great, and it passes all the tests, then we'll keep it. If it takes you longer, then no, we'll fall back to what we have. Take a few days, it works, it passes all the tests, great. Yeah, it's a bit longer code, but yeah. Is it faster? I'll leave that to as an exercise to test. And finally, because we all know that Java stopped with version 8, yeah? Finally, we get Java 8 with functional streams, and we get this wonderful code with 2 stream methods. And that passes all the tests. It looks very readable, maintainable, et cetera, et cetera. And we could go on like this. In conclusion, what I would suggest to try and streamline our decision-making and make it something that's beneficial to users and to us as well is a couple things. So don't make things overcomplicated when they are simple and clear, when everybody knows the best practice. Develop and use expert knowledge and experience. Apply plan, do, study, act, maybe TDD when it's applicable, when you have a slightly complex problem that you need to explore, you need to do fast iteration over. Do the next right thing when you're in complexity, and keep options open. And hopefully with that, you will be able to choose the right tool for the job. Thank you.